Hello, this is John Baugh again, and this is session 6, recorded video lecture, and it covers chapter 7. Today we're going to go over some of the stuff in chapter 7, which covers arrays and vectors. If we look at today's information for the syllabus, we will see, even though I'm recording it on the 10th, some of you are taking your midterm today, the arrays and vectors are what this is actually for. Note that the Project 1 due date is coming up very soon. Project 2 is, although I'll post it now, it's officially assigned on the 17th, week of the 17th, which isn't here yet, so you get a little more time to work on it. The topic we're going on over today is arrays and vectors, and that's in the chapter 7 of the Deedle book. I've uploaded basically some notes for this particular class, and it goes over the basics of arrays, and it also goes over vectors as well. In the video lecture, I'm also going to cover a little bit more, including some information about the array class, which is new to the Deedle books. They don't typically seem to cover that topic. But first of all, we need to get an idea about what is the array. What is an array? The way I'm going to describe it is that we have variables of different types, and each of these variables takes up a certain amount of memory. Okay, so I might have a variable sitting in memory with an integer in it. 1 second. Alright, hopefully this doesn't freeze on me. Okay. Okay. So you got this. You've got this variable sitting in memory. That's an integer variable, as we see, and it's got the number 15 in it. Okay, so that variable might have the name mynum. Okay. So that works. We've got a variable named mynum sitting around in memory, and it's got the data 15 inside of it. We might, let's say we have to keep track of a bunch of different numbers. I want 20 in there, and let's say we'll call this mynum2, and so on. Now this isn't too bad if we only have a couple numbers, or if we have numbers that are supposed to represent specific things, like say an interest rate, or a maximum age, or the number of times you want to go through a loop, etc. These are all supposed to be individual integers. But if we have a lot of information we're trying to maintain, for example, maybe a let's say we want to maintain a list of weights of individuals in a particular class. Well, let's say there's 20 of them. Okay, I don't know about you, but I don't want to type out mynum, mynum2, mynum3, mynum4, mynum5, or my weight 1, my weight 2, my weight 3, etc. So the answer to this problem is that we have a type of data structure called an array. Okay, an array. And an array is actually a set of contiguous memory. It's a homogeneous collection of data, which means that each of the individual components of this array, which we'll see in a minute, are the same. It's homogeneous. Okay. We might name the array my int array, for example, and then at each individual location in here, sloppily draw a couple things here. Let's say we have my array, and it's got, okay, it's got 1, 2, 3, 4, 5, 6, 7 cells in it. Okay, and so I might put 4 here, and 10 there, 6 there, 7 there, 94 here, 1 there, and 12 here. Okay. Now, in this array, we use one name myInt array to refer to the entire array. You might ask yourself, well, what do I do with each of these individual numbers? How do I get those back? Well, each of these is governed by what we call an index. An index. Okay, so I'm going to type that here, index. And let me move this over here so we have a little more room to work with. Okay. Oops. Carried away there. All right. So you've got myInt array here, and then there's an index for each of these numbers, for each of the individual elements within the array. Okay. So we call each individual section, we could say it's an element within the array. So I'd say 4 is the first element in the array, 10 is the second element, etc. But the indices in an array in C++ and many high-level languages, possibly most high-level languages, are indexed from 0. So the actual first index is 0, the next one's 1, then we have 2, 3, then 4, 5, and 6. Okay, this is if we have an array that has 7 different elements in it. So we would say that this is myInt array at 0. Okay, let's look at what this looks like in code. With a basic array, we're going to have, we don't actually have to include anything for this. I was testing something earlier. For a standard built-in C++ array of integers, you basically just have to say int, same name of the variable, and let's say myInt array. I'll keep it consistent, and we want there to be 7 different elements in it. Okay, 1, 2, 3, 4, 5, 6, 7. That's the count of the array, or the size of the array. So we say int myInt array 7. Okay, that's how we declare, and it reserves the memory for us. 7 integer slots of contiguous memory. They're homogeneous. That means I can't put a string in at location 0 and then an integer at location 2 and a double at location 3. It doesn't work that way. And then to access each individual component, to keep with consistency, we'll go with what's actually in this example. We have 4, 10, 6, 7. I'll write this down. 4, 10, 6, 7, 94, 1, and 12. Okay. So we say myInt array at 0 is equal to 4. So that places 4 in the first location of the array. MyInt array at 1 is equal to, I think it was, my handwriting's sloppy. Okay, 10. Okay, myInt array at 2 is equal to 6. MyInt array at 3 is equal to 7. MyInt array at 4 is equal to 94. And myInt array at 5 is equal to 1. MyInt array at 6 is equal to 12. Okay, so a couple things to note here is that we can access and even change each individual element within the array. Okay, each individual index. Each of these is called an index. That's like the little location within the array. You can think of an array as like myInt array would be referring to the apartment building. When I use the name myInt array, the runtime environment compiler, they know that I'm talking about this particular array, which is sitting here. If I want to access an individual element, I have to use these numbers, these indices. Okay, each one's called an index, and together, plural, is indices. So you might hear some people say indexes, but indices is generally used more. So you've got, at index 0, we have the number 4 living there, which is the same we have in our code, same thing we have in our code. At location 1, which is actually the second element in the array, that's the number 10, okay, and so on. So you can think of the array as the apartment building and the indices, or each individual index, as an apartment number. Okay, so it tells you exactly what apartment number you're looking for. Now, why is this useful? Well, later on, I can access some of this information. Let's say I want to print out all of these. I could do this. I know that I have 7 elements in the array, and I'm going to print out my int array. And notice what I'm doing here. Instead of having to print each of these out individually, once I have the data inside of them, I can say, see out my int array at I, and then I, since it's changing, goes from 0 to 6, right? Because we end when we get to 7. 0, 1, 2, 3, 4, 5, 6. It will print out each element one at a time. So let's build this and run it and see what it does. Okay, and pretty much what we expected, right? Okay, because those are each element that lives in the array. So the first time through this loop, I is 0. Okay, since I had a question about this, I'm actually going to clarify something with for loops. With a for loop, in the header, this first part only is called once. Okay, so unless it's inside of another for loop. Okay, if it's inside of another for loop, once this one gets terminated and it goes to the next iteration of the outer for loop, this one will occur one more time. But within the context of this loop, this only occurs once, so you initialize it to 0 once, so it does not get initialized to 0 every time you go through the loop. That would be useless and it would be an infinite loop. The second thing right here is the loop continuation statement right here, I less than 7. So as long as I is less than 7, the loop will continue. That is tested at every iteration of the loop. This right here, the I++, this also gets called with every iteration of the loop. So this first part only gets called once. So some of you were confused by that, so I felt I should clarify it a little bit. Okay, so arrays are homogeneous collections of data, or collections of homogeneous data. You use indices, which is the plural of index, to reference a particular location in memory. One other thing to note is that the highest index in an array is the length of the array, or the size of the array, minus 1. Okay, let's see if this is true. When we declared our array, we used 7, because that tells us how many elements we want in the array. That tells us the size of the array. We're saying, I want an array, I want you to reserve 7 slots of memory for me to put integers in. Okay, it's as if we just typed out 7 integer variables, but the advantages we get with an array is we can refer to them by one name and then refer to each individual component with just an index. We don't have to have a sloppy collection with all different names and everything, and it's not very convenient to do that. But if we do this, if we use the loop down here, this is another instance in which this is more effective, because we can actually just use the indices by going 0, 1, 2, 3, 4, 5, all the way up to 6. Since arrays are indexed by 0, that's why they only go up to the size of the array minus 1. So the first element is at 0, the second element is at 1, third, fourth, fifth, sixth, and seventh element is actually at 6, index 6. Okay, does that make sense? Think through it for a few minutes. If you need to pause, that's fine. Just try to make sure you understand that. Another way to initialize a standard array is, let's say I have an array of size 3, which means we have 3 elements indexed up to 2. So we have something at element 0, something at element 1, and something at element 2. You can use what's called an initialization list. Let's say I have 12, 54, and 6. Okay, and that will actually initialize the 0th component at 12, the first component or component 1 at 54, and then the second index at 6. Okay, so that's another way to initialize elements of an array. Another shorthand array, or shorthand, is if you just do this. If you say int my array of 3 and then equal to 0, the only thing you can really do here is with 0 to clear the elements. If you just use one element here, this is a real shorthand, and the compiler picks up on the fact that you want every element within the array to be indexed to the value 0. Okay, so this is kind of the equivalent of initializing an array or initializing a variable to its 0 value. Like if I said int a equals 0, or double d equals 0.0, or string l equals the empty string, or what have you. Okay, double quotes with nothing in it. So that's the basic arrays. Now, another thing I want to bring to your attention, I don't even know that they don't seem to cover basic arrays extremely well in the book, so I just definitely wanted to show you that. But if you want to declare arrays using the standard template library, then you can go to page 281. This is an actual class named array, and one thing to note, again, we call this type of array a static array, as opposed to a dynamic array, which we'll talk about in a little bit, called a vector. Okay, so static arrays are just the array data type, and dynamic arrays are the vector data type. The static array requires a library to be included, because it's usually the name of the data type that we're going to use. So the thing that I want you to note is that the array is declared by using the word array. Okay, that's a data type as far as this is concerned now. And then you have in less than sign and close and greater than sign. Inside of those, you'll notice that we have IntelliSense pops up even to tell us what we're looking for. You have a type name and also what they call a SizeT. Okay, the SizeT is the size of the array. Okay, we'll talk about that in just a minute a little bit more. Let's say we want an array of integers of size 4. Okay, we want to call that my array. All right. So this array right here, the first parameter inside these parentheses, this is called templating. We haven't really gotten into templating yet, but this is a template, or in some languages they call these generics. This allows us to make data types that can contain pretty much anything. I can have an array of integers, an array of doubles, an array of strings, an array of cows, horses, dogs, people. It's whatever class you invent later on. So the people that invented this class right here, the array, had no clue what kind of class you might invent later on. Like you might make a person class, or an employee class, or a SpongeBob SquarePants class. They have no idea what you're going to do. But since they programmed it generically using a technique called templating, or generics, you can put pretty much any parameter, or any type, as the first parameter. The second parameter here, and it's not a function, so be careful. Even the syntax is different. See, there's less than and greater than signs. But you have the data type here, so int, float, dog, horse, whatever you have. And then the second parameter is the size. Okay, so this is, we'd say, similar to int my array of size 4. Okay, the difference is that the array class actually has some useful member functions and things like the size member function, so that would allow us to know what size we're using. So let's do this. Let's say we want to initialize the elements in this array. We'll say int. Well, actually, here's what I'm going to do. I'm going to get back to this. The SizeT element is actually used very frequently with arrays. It's considered more appropriate, actually, because integer could be negative numbers. SizeT is used for arrays because it's an unsigned integer, and SizeT is a data type. It is declared in the CSTD-DEF, or C Standard Definition library. You'll notice we're not directly including C Standard Def library, but it is inside of other libraries, for example, array. It's already included in there, so we don't need to worry about it here. But it is a data type. Just think of it as an integer. It's just an integer that can only take on 0 and positive values. It cannot take on negative values. So SizeT is considered more appropriate for array indices. Okay, so SizeT, say I equals 0, I less than, and now here's where it gets interesting. My array dot size, okay, and we'll say I plus plus. So this is how we're initializing the array. We'll say my array at I is equal to, let's just say I times 3. Now this is kind of arbitrary here. I could loop through here and ask the, I could ask the user to input integers, but in this it's going to take whatever I is and multiply by 3. So we're basically going to get the multiples of 3 up to 3, really. That's we'll see what that looks like in just a second. Now, the other thing that we can do is use this on the reverse. We can say for SizeT j is equal to 0, j less than n dot size, j plus plus, not n, sorry, my array dot size, j plus plus, and we can print out the elements in the array. Okay, so you use it essentially in the same way that we used our standard array, our standard built-in C++ array. It failed, so let's figure out what's going on here. Oh, I said I. That needs to be j, because we have a j in here. Alright, I could reuse I, by the way, because I up here is only local to this code block. We talked about scope last week. I could reuse I down here, but this is, I think, for clarification purposes. Okay, so there we go. 0, 3, 6, and 9, which is pretty much what we expect, right? So, because this loop right here starts at 0, so it stores 0 times 3, which is 0, then 1 times 3, which is 3, 2 times 3 is 6, and then 3 times 3 is 9. When it gets to 4, when I gets to 4, the array's size, since we declared it as 4 originally, it breaks out of that loop, and we're done. Okay? So that's the array list. Now, these are static arrays, which means they cannot grow. I can't just say, add a new element and everything's hunky-dory. Okay, you can't just do that. You'd have to copy over the elements, and in general, arrays are more efficient with the memory than are vectors, which we'll get to in a second. But vectors are a lot more flexible. Okay, now you may not be able to use this if you have an older compiler, older IDE, but I'm going to show you another syntax that is new to the C++ 11, which is the newest standard. The standards hadn't been modified for many, many years, and just recently they created a new standard, which is called C++ 11. That's why on the cover of your book it says C++ on a program, and it's got like 11 with a spotlight over it, because it does show you some of the new features of C++ 11. So I'm going to do that. Now, when I printed this out, I can use the SizeT syntax right here and go up to the size of the array and keep printing each element. I can do that. But here's what I'm going to do. Okay, I'm going to comment out the selected lines right here, just for a temporarily, and I'm going to use something called the range-based for statement. Okay, so this is slightly different than the syntax of the earlier for statements we've dealt with. Basically, I'm going to say what type of element is inside my array. First, that's the question you ask yourself. And the answer is int. Okay, so, or I'm sorry, what, yes, yeah, it's int. So I say int item, then you use a single colon, and then the name of your array. And then I just see out the item. So the thing that we do here is that we're declaring a variable essentially local to this loop, and this does not act as a counter. Be very careful with that thought. This is range-based, so that means it knows how many elements are in the array, and each item, each time we go through this loop, it will print out the first item, then the second item, third item, up to however many items are in the array. So let's see, this should essentially do the same thing that our last one did, which it does. See, it does the exact same thing. Okay, so that's more convenient syntax. It is more appropriate for just printing out stuff. If you need to modify items in a loop like we did up here, it's not really appropriate for it. We want to use the count-based array here. But for shorthand, this might be helpful for you. Some languages have a for each loop in them, like C#. C# has a for each loop. That's essentially what this is. Okay, it's a for each. For each item in the array, print out the item, or do something to the item. Okay, use it in a calculation. All right, so those are range-based. We don't require a counter. Another thing that you might want to be familiar with is the multi-dimensional arrays. Okay, multi-dimensional arrays are on page 304. They show you different information about multi-dimensional arrays. I want to show you first the old syntax if you're using just a standard C++ array, and I want a, let's say, a 2D array, we'll say 2 by 2, or int my 2D array size 2 by 2. Okay, my 2D array at 0, 0 is equal to 15. My 2D array at 0, 1 is equal to 20. My 2D array at 0, 1, 0 is equal to 34, and my 2D array at 1, 1 is equal to 22. Okay, so that, you can think of a 2D array as basically kind of like a table, which you've probably seen in something like Microsoft Excel. It has rows and columns, okay, like Microsoft Excel does. So in this case, since it's a 2 by 2, we index them from 0, both of them. And let's just do a blank workbook real quick here. And let's say I have, so it's 15, 20. So 15, 20, oops, 20, 15, 20, 34, and 22. 34, 22. So this right here is a 2D array. Okay. And at location 0, 0, we have 15. And the first number in a 2D array represents the row. Okay. And with a spreadsheet, for example, the rows are the things that go horizontal. So this is row 1, right? And then the columns are vertical. So column A, column B. So if I want element 0, 0, I go here. If I want element 0, 1, I go there. Element 1, 1, 0, I go here, because it's the row 1 and element 0, and then row 1, element 1, so that's at 1, 1. Okay, just like here. That's a 2D array. Often we print these out by using a standard nested for loop. Okay. All right. So I'd say my 2D array at I, J, and we'll see if this works. Okay, so it does. 15, 20, 34, 32. If you want it to look a little bit more like the table that we had before, then notice that these represent the columns, because the columns are changing faster than the rows. Okay, so we start in row 1, we print out column 1, then column 0, then column 1, then we do a new line, and then column row 1, column 0, column 1. Okay, so I'm going to actually add an extra space there. Build it. Start without debugging, and you'll notice we get our little table here. This looks very similar to what we had in Excel. 15, 20, 34, 22, right? 15, 20, 34, 22. Okay. Multi-dimensional arrays can be extended to, as long as you have enough memory. For example, 3-dimension, 4-dimension, you could just keep adding sets of brackets. Now, the other way you can do it is you can use it with the standard array data type, or the standard template library array data type. And you can do something like this if you want to. Let's say array, and since a 2D array, now this I haven't posed it like this before, but if you think about it, a 2D array is really just an array of arrays. Okay, so each element of the first element in the array is like another array, and then we give it another index to tell it the specific element within that second array. So this array, the outer array, has an inner array of integers. We'll say that it's got 2 columns, okay, and then 2 rows, right? And we're going to call this one just my 2D. Okay. Now see if this makes sense to you. Pay attention here, because we have an outer array which has 2 elements. This is the first element in and of itself, and this is the second element. So this first array has only 2 elements. And what are those elements' data types? Well, they're an array type, but it's an array of integers. So we have an array of arrays. Okay? Because remember, the first parameter is the data type. In this case, it's an array. Since an array is a class, and we have an instance of it, that would be an object, correct? So that means we do have the ability to make an array of arrays. All right? It's pretty snazzy. Okay, so same thing here. We would say my 2D at 0 equals 15. Oops, we have to do this. We have to put the 2D syntax. 15, my 2D at 0, 1 equals 55. 2D, I could have just left the code from last time, but no harm in typing. My 2D at 1, 1 is equal to 25. Okay, so I can use the standard syntax, but this time I'm going to say my 2D dot size, all right, and I++, and then you might wonder, well, how am I going to do the inner loop? Well, it's my 2D at I dot size. Okay, since they're all the same, you could just say my 2D at 0 dot size. It doesn't really matter because they're all the same, essentially. And we're going to print out my 2D at I, j, and I'm going to do the same thing. I'm going to put a few spaces here and then an indel here. Let's see if we get what we expect. Okay. All right, there you go. So we've got 15, 55, 54, 25. That's what we expect. All right, so that's pretty handy. Those are multi-dimensional arrays. Okay, the next thing I want to cover are is the vector data type. That's on page 314 in the 9th edition of the book. And the array types we've seen so far are they're what we call static arrays. Let's see what happens if, let's take the 2D element out of here, and we're going to just do a standard array here so it's more clear. We'll say that, and then we'll say it's of size 2. Okay, so my items at 0, 15, my items at 1 is 50. Now, here's something that a lot of, especially novice programmers, but programmers in general do, is they'll accidentally think, okay, well, the highest index of the array is the number I specified as the size. That's not the case, because we've just exhausted the space in the array, because we said we want 2 elements to be able to fit in the array. Well, how many elements do we have here? 2. So, okay, so we've got these 2 elements here, and we've exhausted that. So what if we add another one? Okay. Now, this could be a problem. This is a problem because we're going outside the bounds of the array. The array will not, does not have capabilities for adding new elements dynamically, because we said we want 2 elements, and that's what we get. So if we try to access this, you're going to notice that the compiler does not catch this. Okay, the compiler does not care. Okay, but when we're at runtime, do you see this right here? Debug assertion failed. It'll say, and don't freak out when you're working on your own assignments and you get an error. Read it. Okay, a lot of people look at it and think it's gobbledygook. They can't possibly understand it. What does this say right here? Expression array subscript out of range. Okay, the subscript or the index is out of range. Okay, that means that I'm going to abort this to say we're going to kill the process. That means that this right here is out of range. Now let's say we couldn't locate where the problem was, then we could say start debugging. Okay, instead of start without debugging, we want to start debugging. Here's your first real lesson on using the debugger. If we start debugging, notice that if we didn't set any breakpoints, we'll hit abort here. It didn't seem to find anything, but let's see what the problem is. If I click over into the gray area and then say start debugging, the first item I can see right away that my items at 0 is 15. Okay, I can use the debugger to step over, so it's F10. Okay, step over, that goes to the next element. So I'll notice down here the memory says that I've got 15 there. If I hit